Now we will study refraction from rarer medium to denser medium at convex spherical surface for virtual image. मैंने आपको बताया था दो केसेस होंगे. जब आपकी इमेज नॉर्मल की तरफ कम बेंड करेगी तो वर्चुअल इमेज फॉर्म होगी और ज्यादा बेंड करेगी तो रियल इमेज फॉर्म होगी. एंड वी हैव स्टडीड द केस ऑफ रियल इमेज. इन दिस we will study about the virtual image. So let us draw the diagram. This is the convex spherical surface. This is tensor medium. With refractive index nu2, and this is rarer medium for refractive index mu1. As convex surface is facing the rarer medium, so that's why we are saying this convex spherical surface. This is midpoint of the spherical surface, and this midpoint of the spherical surface is known as pole. From the pole we will draw a line that is known as principal axis. So this is pole, this is rarer medium, this is denser medium. Rarer medium with refractive index nu1, denser medium with refractive index nu2. Now for the virtual image, we will take the point object very close to the pole. So suppose this is the point O. At point O, at the principal axis, we have placed our point object. So this is our point object. From the point object, one ray will go and strike the surface, spherical surface normally, and it will pass undeviated through the spherical surface along the principal axis. Second ray from the point object will come like this. It will be incident on this spherical surface at a point. Let us give it a name. At point A, it will strike. Second ray from the point object will strike this spherical refracting surface at point A. You know, the point where the incident ray strike the surface, we will draw the normal. So let us draw the normal. So this is the normal, and suppose this normal will intersect this principal axis at center of curvature. So as I have told you in the earlier video, कि this would be its original path, but as the ray is traveling from rarer medium to the denser medium, so it will bend towards the normal, and in this case it will bend. Its degree of bendness would be less. That means it would bend this much. So this will not go along this path, but it will go like this, A, B. And you can see these two rays, when you will see from this side, they will not meet actually at this side, but when we will produce this ray back, so they will not actually meet, but they will appear to meet somehow backside to the object. So we will produce this ray backside, and this will intersect the refracted ray PC. AB and PC both are refracted rays. When we will produce this AB to the back side, so this refracted ray AB will intersect this refracted ray PC somewhere at this point, and this point is I, where image of this point object is formed, and this is in front of the this convex spherical surface. Image is formed in front of the convex spherical surface. So this image is virtual image. So here image is formed. Again we have to do the same thing. This is normal, and this is incident ray. The angle between incident ray and the normal is known as angle of incidence. So this is angle of incidence. This is refracted ray, ray is refracted along AB. So AB is refracted ray, this is normal, so this angle is known as angle of refraction R. Angle between the incident ray OA and along the principal axis. Incident ray and between this principal axis object, where object is placed, here angle is alpha. The angle between this ray and the principal axis is known as beta, and again this angle is known as gamma. So we have to do again, we will apply Snell's law at point A and we will write Snell's law, applying Snell's law at point A, we will write mu2 by mu1 is equal to sine of I over sine of R. And when angle I and angle R are very small, in that case we will replace sine of I and sine of R simply by I and R. So it is I and this is again again cross multiplying. So I multiplied by mu1, या फिर we can write mu1 I is equal to mu2 R. Simply angle I and angle R we have to find. So angle I is angle I in triangle. Angle I is external angle of triangle OAC. So angle I is equal to angle alpha plus angle gamma. In the same way, angle RC. Angle R is external angle of this triangle, this one. AIC. In triangle AIC, angle R is equal to beta plus gamma. So angle R is equal to angle beta plus angle gamma. Simply replace angle I and R in this equation. We will get mu1 into I is alpha plus gamma is equal to mu2 into R is beta plus gamma. Again we have to take tangent of alpha, tangent of gamma and tangent of beta. Tangent of alpha. For tangent of alpha, we have to draw a perpendicular from A. We can say we have drawn AM perpendicular on IC, and we will write now alpha in triangle AMO, yeah, OAM. In triangle OAM, alpha is AM by OM, so mu1 AM by OM. In the same way, gamma is in this triangle AM by MC. AM by MC is equal to mu2. Beta is this triangle AIM. Beta is AM by MI. AM by MI plus gamma. Gamma again AM by MC. AM. From both the sides AM we will take common and it would be cancel out. So we are left with mu1 into 1 by, we will do one more thing, because M curvature is very small and M is very close to P, so we would replace M by P. So it would become OP 1 by M की जगह हम P से again replace कर देंगे PC, and this is equal to mu2 into 1 by PI plus 1 by PC. Now OP, the distance pole से object तक का distance known as U. PC is R and PI is again pole से image, so V. OP is minus of U, so mu1 into 1 by minus of U. PC is R, so 1 by R. इसको मैं यहाँ से रब कर देती हूँ. mu1 into 1 by OP. OP is u, so 1 by minus of u plus 1 by PC. PC is R, so 1 by R. This is equal to mu2 into 1 by PI. PI is minus of V plus 1 by PC. PC again 1 by R. So ये बन गया हमारे पास. अगेन क्या करेंगे, ये mu1 है, इसको इधर ले लो. देखो mu1 by minus of u plus mu1 by r is equal to mu2 by minus of v plus mu2 by r. ये जो mu1 by r है उसको उस तरफ ले जाओ, mu2 by v को इस तरफ ले जाओ. So it would become mu2 by v minus mu1 by v, and this is equal to mu2 by r minus mu1 by r. ये हमने कुछ mu2 by v minus u. Now we can write one more thing. mu1 by minus of u plus mu2 by v, and this is equal to mu2 minus mu1 by r. This is the result for the virtual image when refraction takes place from rarer medium to denser medium at convex spherical surface. In the next video, we will learn about refraction from denser medium to rarer medium at convex spherical surface. Thank you.